So for question 16, it's just more like a kind of a qualitative analysis of the circuit. So we just have to figure out what's the output waveforms on the same graph as the input, and then show the peak values assuming ideal diodes. So for the first case, the voltage Vs will basically, on the negative half cycle, it will basically allow current to flow, and then the capacitor will start to charge. And once it fully charges, then it will stay charged with that um, 5 volts voltage. And then once it basically, once we have like this capacitor fully charged, then what we will observe at V out is just the input voltage plus that voltage of the capacitor. So it's plus minus here, so we will fully charge with 5 volts on the negative half cycle. It will keep like fully charged. Then this diode here will turn off, and then what we will observe is just Vs plus this 5 volts. So overall, the output voltage, I will just draw over this plot here. So once we put it, it wouldn't happen like exactly at instant speed, so it will require like some time for the capacitor to charge. But overall, once it fully charges, then we would observe something that is just this waveform here. So we go up to all the way to 10, goes back to 0, all the way to 10, and then goes back to 0. So this value here, it's going to be 10 volts. So it's basically going to offset that input signal by 5 volts. For this second circuit here, it's kind of the same thing, but the capacitor will charge with then a positive voltage of 2 volts, right? So it's going to be 2 volts here. And then once it fully charges, then again this diode here will be turned off because there is no more current flowing, right? Because it will be always reverse biased. And then the output voltage that we would observe is just minus 2 plus the voltage surge. So it's going to be something like this. Okay, so this is minus 10 volts. Okay,